Here we're talking about reaction basics, some things that all the various chemical reactions have in common. Well, for example, first off, chemical reactions can either remove pollutants from the atmosphere or add them to the atmosphere. And some examples of reactions that add pollutants to the atmosphere are the chemical reactions that create ozone and photochemical smog. So this is just a picture of some photochemical smog. In general, nearly all atmospheric chemical transformations are driven by sunlight, so the energy in sunlight interacting with the gases or particles in the atmosphere. And most air pollutants, most reactions happen because the air pollutants are oxidized, although not usually by oxygen. So they're usually oxidized by highly reactive oxygen compounds like ozone. So ozone is a big driver of different chemical reactions, and free radicals. These are compounds that have a unpaired electron, which you usually see represented as sort of the atoms contained in the compound with a little dot after it. So this is a hydroxyl radical, and this kind of nicely illustrates what ozone can do in the troposphere by creating a free radical. So here's ozone. It interacts with some near UV light, sort of jiggles a model, breaks off a piece, and you end up with these unpaired electrons on an oxygen atom and a normal oxygen molecule. Well, this molecule goes on to interact with water, and it creates these two hydroxyl radicals that are wanting to be something else, so they'll tear other molecules apart. Some other radicals that you find are the peroxyl radical here, and other sort of more carbon compounds are alkyl group and acyclic alkyl groups that are radicals. So all of these things sort of further drive atmospheric chemistry. We're not going to go too much into that. I just kind of wanted to introduce you to the idea in general that ozone is a big player. And then there are these free radicals floating around driving reactions in the atmosphere. So there are basically in the atmosphere two kinds of reactions. One is called homogeneous reactions. All that means is that all the reactants are in the gas phase. And then there are heterogeneous reactions, and this becomes more important when we start talking about ozone depletion in the stratosphere. But heterogeneous reactions involve more than one phase. So that would be like a gas and a liquid, or a gas and a solid. So there may be reactions that, for example, occur more rapidly in water. So there may be heterogeneous chemical reactions going on in water droplets in the atmosphere, or on solid surfaces, so maybe on ice crystals that catalyze reactions that might otherwise happen too slowly or might not happen at all. And this is what happens with stratospheric ozone chemistry, which we'll hopefully have a chance to talk about in class. Okay, so summary, this is sort of a brief section. Chemical reactions can remove or add pollutants to the atmosphere. Sunlight drives most of these reactions. And most air pollutants are oxidized, though not usually by oxygen, but by reactive oxygen species like ozone or free radicals. And then we also talked about some other terminology. Homogeneous reactions just means all the reactants are gases, and heterogeneous reactions just mean that there's a gas and something else, like in a liquid or a solid. And water and solids can often speed up reactions or act as catalysts in these reactions. And that's it for this video. Thanks for watching.